In part 2 of the video, we will further continue the multiple choice question that is from the solid chapter. A solid AB has sodium chloride structure. If the radius of the cation is 120 picometer, the minimum value for the radius of the anion will be. There are 4 options given. So we will solve it. Sodium chloride has octahedral structure. So the radius ratio will be radius of cation with respect to radius of anion. It is equal to 0.414. Actually, this value will be in range 0.414 to 0.732. Here we will find the minimum value. So we will use here the minimum value, that is 0.414. So radius of cation divided by 0.414 is equal to radius of anion. This formula is obtained by rearranging this formula just by the shifting of 0.414 with radius of anion. Now the radius of cation is given, that is 120 picometer. So putting the radius of cation as 120 picometer divided by 0.414, that will produce radius of anion. So among these options, option B is the correct answer, that is the 120 divided by 0.414. The number of atoms per unit cell of a simple cubic, face center cubic and body center cubic are 1, 2, 4, 1, 4, 2, 4, 2, 1 and 2, 4, 1. So the same table for the information will be used. In simple cubic, body center cubic and face center cubic, the number of atoms that are present in simple cube is 1, body center cube is 2 and face center cube is 4. So the question is about simple cubic, face center cubic and body center cubic. So we will arrange all these values according to the question. So simple cube will be at first position, face center cube, that is 4, at the second position, and body center cube, that is at third position, that is 2. So 1, 4 and 2, that will be the correct answer, that is option B. In a crystal, the atoms are located at the position where potential energy is maximum, 0, minimum, infinite. In a crystal, the atoms are located at a position of minimum potential energy in order to attain greater stability. So they will have minimum potential energy, they will be stable. An equilibrium exists between the attractive and repulsive forces when the bond is formed, and it will gain greater stability. So that are present at the minimum potential energy in order to gain this stability. The number of atoms in the unit cell of a cube is 0, 1, 2 and 3. So if we look at the cubic structure, here the 8 atoms that are located at the 8 odd corners of the unit cell. But these 8 corners are shared by further 8 unit cells, which means that this atom has the not atom equal to 8, but it has the atom that are equal to 8 multiplied by 1 by 8. But because it will be divided by 1 by 8. So each corner we have 1 by 8 atom. These are 1 by 8 atoms, not the 8 atoms, because these are shared by 8 for the unit cell. So 8 corners we have 1 by 8, that are the atoms that are present at each corner, and there are 8 corners, so we will have 1 atom in the simple cube. Here it is also obtained from this information table. Simple cubic, 8 divided by 1 by 8 that are present at the corner. There is no atom at the faces, there is no atom at the center. So we will have 1 atom. Total of 1 atom is present in simple cubic. Which one of the following has highest lattice energy? Sodium chloride, potassium bromide, lithium fluoride. So the lattice energy is inversely proportional to the size of the cation and anion. Among the given compounds, The size of the cation and anion is smallest for lithium fluoride because both are present at the top of the group, and we know that when we move from top to bottom the size increases. So fluoride among all the chloride and bromide is present at the top, and sodium, potassium and lithium is present at the top. So these both are present at the top, which means that these both have smaller size. When these have smaller size, so they will have greater lattice energy. Potassium crystallizes in a body center cubic structure. The coordination number of the potassium in a potassium metal, that is the body center cubic structure, that is 2, 4, 6 and 8. The unit cell of the body center cube has one atom at the each at corners and one atom in the center. Thus, the atom in the center remain in contact with 8 corner atoms. So, coordination number is that number, the atom that are surrounded by the central metal atom. So, here the central, in case of body center cube, one atom is present at the center that is surrounded by the 8 other atoms. So, the coordination number of the body center cube is 8. So here the potassium crystallizes in a body center cube, so it will have 8 coordination number. In an ionic crystal of the general formula AX, the coordination number is 6. The value for the radius ratio is in the range. So there is a range of ratio given. So we will use the information table. Here the coordination number 6 is given. So 6, that will have the octahedral structure, and the radius ratio will be 0.414 to 0.732. So among these options, option C is the correct answer. The number of atoms in the unit cell of face center cube is 2, 4, 6, 8. So first we will know about the face center cube. As the name indicates, it is face. Each atom is present at the face. So there are 6 faces in a cube. So which means that there are 6 extra atoms that are present in a face center cube, along with the 8 atoms that are present at the corner. So here the red atom represents the face atom, and the gray or the black atom represents the corner atom. So there are 8 corner atom present, but these 8 corner are shared by 8 further unit cells. So these will be divided by 8 because these are shared by further 8 unit cell. Similarly, each face is shared by 2 unit cells. So this atom will be shared by 2 unit cell. So each face atom will be divided by 2. So there are 6 faces, so we will divide 6 by 2. And there are 8 corners, each have 8 atoms. So all these 8 atoms will be divided by 8. So there are equivalent of 4 atoms. At 8 corners, 1 by 8 of each, that will produce 1 atom. So 8 corners and each will have 1 by 8. So 8 multiplied by 1 by 8 will produce 1 atom. 6 faces are present in the cube, and each face atom is shared by 2 unit cells, which mean that each face will be divided by 2 and it will produce 3 atoms. So 3 plus 1, that will produce 4 equivalent atoms. This is the simple information table. In case of face center cube, 8 corners are present and each will have atom 1 by 8. So we will get the 1 atom. 6 faces are present and each 6 faces are shared by 2 atoms, which means that it has 1 by 2 atom. So 6 multiplied by 1 by 2, it will produce 3, and there is no atom present in the center, that is 0. So 3 plus 1, it will produce 4. So 4 is the correct answer. In silicon crystal, each atom is covalently bonded to dash neighbors 2, 4, 6, 8. The tetravalency of the silicon is surrounded by 4 oxygen atoms. So here if we look at the silicon, it is surrounded by 4, 1, 2, 3 and 4. It is surrounded by 4 neighbors, or we can say it is surrounded by 4 oxygen atom.